We can then move to our reconciliation. Now what we have here is an out-of-the-box model, which I showed you before, which allowed you to point to a source and a target and create these tests for us. What I'm going to do is not to save time today, I'm not going to set them up manually. I'm just going to go to my pre-created tests for reconciliation, profiling, reporting, which covers transformations as well. And here's my completed one. And we can have a look at how we can compare data using these pre-built models. So I've set up all these tests already, and what we're going to do is have a look at some examples. So one of the things we can do is compare data from the SQL Server database to Snowflake, and this is the migration use case we were talking about. So for example, I can connect to a table using my pre-built model here. I can go to my drop-down list, just like you saw in the wizard. All those connections are saved, and you can set up as many as you need to, and I can connect to my SQL Server database, run my query, and connect to my target, which is Snowflake. Along the way, you can set up settings like, is the first row contains the column names. I can say true. I can remap column names if they've changed completely, like you saw me do in the wizard for those types of tests. Here we would just remap them ourselves, and this avoids you having to write a lot of SQL queries. You can trim out double quotes in the headers. When I uploaded that data, a lot of double quotes appeared in Snowflake, so it had a mismatch, which would create a lot of errors, but you can see all the sort of transformations or formatting changes can be taken care of using out-of-the-box functions here, like substringing, uppercase, lowercase, removing commas and dots. And of course, you can write your old SQL queries as well. Then I'm going to point to my target, which is my Snowflake database. I can run my queries there, apply similar options if I need to, and my row key in this case, I'm just using all my source row columns as my row key, and you can type them in yourself. You can use comma semicolon to separate them, and then you can write some reporting. So what we're going to see is all of our reporting is stored in the execution list, like I mentioned, but when you're looking at terabytes of data, millions of records, this gets very tricky to read in our execution lists. Those report on a high level, but if you want to see the data and pinpoint source and target fields, that's where we can show you that. And we can create these out-of-the-box HTML reports, so you can save them to a shared folder somewhere that everyone can access. And you can do things like even add tolerances to different field levels or columns where you need to add plus or minus, and then verify that they have a match. Other things we can do, like we mentioned before, is we can also leverage functionality from Snowflake, such as the time traveling feature. So what we'll do is we'll jump over here quickly to Snowflake so you can see what we're talking about. Here's the data I've loaded up. What we're going to do is we're going to compare my data from my SQL Server, and you can see when I run this query, there is 91,394 rows. When I moved it to Snowflake, I only had 8,600, and this was come as the formatting. Some of the formatting changed. So when I uploaded, there were some errors along the way, but this is great to see when you run the comparison what the reports look like. So I left that in. We'll have a look at that, but what we'll also see is, if I jump over here, the time travel function. So what this means is if you run these queries, it basically says I can use a current state and say, what does my data look like right now, and run my query. And I can also go back up to 90 days and say, what did the data look like in the past? This is Snowflake's time travel function. So what you can see here is at the moment, the response is all saying not available. So what I'm going to do is update the response to say yes. And if I run my query now, it's going to tell me the response is saying yes. So the functionality Snowflake has for time traveling means you can go up to 90 days. So what I've said is go back 5 minutes and tell me what the data looks like. And there's my little format for the at and the offset going back 5 minutes. And if I run that query, it's going to say 5 minutes ago it was not available. So basically this is like comparing a source to a target, but we're using the current state to the time travel state. So this is something we can also set up using our pre-built model. If I jump over here, what you'll see is using the source, this is our present state, and my query here, there's my current state query. I'm going to compare it against the target, which is just 5 minutes ago. And the other options are quite similar, but I'm also going to generate that report over here. using different, and you can obviously rename it the way you want, have different settings like max out after 200 if there's too many errors. In my case, that will be the case because I've intentionally set this up, but you can see all the different examples there. I'm going to run these in a second, but I'll just go through the rest. Other things you can do, for example, is I mentioned before we had the healthcare data exchange standards. So what happens when the file is not in a text or CSV format and it's semi-structured? What we can do is we can load up the actual JSON file or XML file. And here's my example here. And you can see here's my JSON file in the different format. What it'll do is it'll load this up into a temporary database, a caching database, and it'll normalize it and create different tables for the different levels within the file. And then what you can do is once it's loaded up to my caching database, I can simply point to my caching database, join up the tables that it will create based on that structure of the XML or JSON file using inner joins. Apply the same column options, like for example here I had to rename certain columns from source to target because the XML file had different naming conventions. When I normalized it in my caching database, it changed. And compare it against the target over here. Okay. So whatever the file structure is, we have out-of-the-box models or database it is. We have out-of-the-box models that point to it and allow you to do this compare from source to target. And we can work with tables and data in different formats. We can create custom modules to normalize that data so that these modules can then be leveraged. So I'll jump over here to my execution list. Let's do a quick checkout of my data. And what you're seeing is all my execution lists for all my data, for all my test cases that I've created, and I've combined them to an end-to-end flow to meet the process of my data warehouse testing. And you can see I've got different tests for different pre-screening, vital checks, reconciliation along the way, and some reporting and profiling as well. So what we'll have a look at here is if I open up some of these, for example, compare SQL Server to Snowflake, go to that log file that was run. Let's look at the results here. It did the compare, it failed. Now, if we have a look at the results here, you can see there's all the data. That's very hard to read. So what we've got is the out-of-the-box reports. If I jump over here, and when you run these reports, if I click on SQL Server to Snowflake, this is the report that's generated when you run that test. There's my 9,000 rows from SQL Server. I uploaded it to Snowflake. It found 100 errors, and that's because I actually told the report to error out after 100 instances. And I can go through and see what actually went wrong. So in this case, there was no differences. We'll see an example of that in a sec. But what actually happened is when I uploaded it, I lost a lot of the data. So I can go to all, it'll load up all the data. And it's basically saying, as we saw in the summary, is a lot of the data that was in the source was not matched in the target. So all this data was found in the source, but not in the target. And we have different levels of errors that you can drill down to. Okay, so that's an example of the data not being carried across. We can have a look at, for example, time travel feature as well. If I double click this one, what you'll see is there was a successful comparison. And this is before I actually did the time travel function. Now that I've done it, if I run it, it will error out and say there's a mismatch. So I can jump over here. Let's see us run one of these. Let's run my time travel test. Just so you can see it's actually going to start its own little BI execution engine. And this is different to the standard Tosca one. It's a lot faster. Like I said, it's in-memory caching. And if I jump over here, you can see now it failed. Come over here. There's my latest report. It's failed. And you can see there's some failures here based on my differences. I can load it up. I can say how many do I want to see. I want to see all of them, for example. Scroll down, move across, and you can see the data changed from source to target. Okay, so it'll pinpoint exactly when something goes wrong. Here I use the time travel function, but again, whatever the data is from source to target, whether you're doing straightforward ETL testing, whether you're doing migrations or time travel like we have here, it'll give you this nice, easy to read HTML report, okay, and pinpoint where the actual errors happened.